Okay, we're going to simplify some trigonometric expressions. The first one we have up is secant theta tangent theta over sine theta. In order to simplify this, we're going to make use of two identities. One is a reciprocal identity that states the secant of theta is equal to 1 over the cosine of theta, because secant and cosine are reciprocals of one another. The second identity we'll make use of is a quotient identity, and it states that tangent of theta equals sine of theta over cosine of theta. So our first step here will be to rewrite each term as either sine or cosine. So let's draw our fraction bar. This sine of theta in the denominator will remain as sine of theta. Secant of theta, we just saw, is equal to 1 over cosine, so we're going to put a 1 in the numerator and a cosine theta in the denominator. Tangent, we see, is equal to sine over cosine, so we're going to put the sine in the numerator and the cosine of theta in the denominator. Now, there's a factor of sine on top and there's a factor of sine on the bottom, so those will cancel each other out, and we will be left with 1 over cosine of theta times cosine of theta is cosine squared theta. Now, we see over here that 1 over cosine is equal to secant, therefore 1 over cosine squared theta will be equal to secant squared theta, and that is our final answer, as we cannot leave our answer in the form of a reciprocal, so in order to simplify it fully, we have to write it as secant squared theta. Okay. Next up, we have simplify secant theta, sine theta, cotangent theta, cosecant theta, and we'll be making use of reciprocal identities and another quotient identity. Now, our reciprocal identities state cosine of theta equals 1 over secant theta equals 1 over cosine theta, and the cosecant of theta equals 1 over sine. And also, our quotient identity states that the cotangent of theta equals cosine over sine. Now, if cosine and secant are reciprocals here, we can use that in order to simplify further. Now, cosecant and sine are reciprocals. Since these two are reciprocals, wherever I see this sine and this cosecant, I will know that I can cancel these two terms out. And the reason is because they're reciprocals of one another. What I'm left with is secant theta, cotangent theta. So once again, we are going to rewrite everything as either sine or cosine. Secant of theta is going to be rewritten as 1 over cosine theta times cotangent of theta from our quotient identity we know is going to be rewritten as cosine of theta over sine of theta. Now we can see that we have a factor of cosine theta in the numerator and a factor of cosine theta in the denominator. Therefore, those two will divide out and become 1. What we'll be left with is 1 over sine theta, and we can't leave our expression as a reciprocal. Therefore, in order to simplify it, we'll use a reciprocal identity once again. We know that 1 over sine theta equals cosecant theta, and that will be our final answer. Okay, next up, Number 3 says simplify tangent squared theta plus 1 over tangent squared theta. Now, we're going to make use of some identities here once again. The Pythagorean identity states that 1 plus tangent squared theta equals secant squared theta. The reciprocal identity that we're going to use states that the cosine of theta equals 1 over the secant of theta. Quotient identity states that tangent of theta equals sine of theta over cosine of theta, and the reciprocal identity states that the cosecant of theta equals 1 over the sine of theta. So what we'll do first here is change the tangent squared theta plus 1 into secant squared theta. So instead of writing tangent squared theta plus 1, we are going to write secant squared theta in the numerator. And we'll write this tangent squared theta. All right, next up, what we will do is once again rewrite all terms as either sine or cosine. Secant is the reciprocal of cosine. Therefore, what we're going to write is 1 over cosine squared theta. Tangent is equal to sine over cosine, so therefore tangent squared would be sine squared theta over cosine squared theta. Now, we have a fraction being divided by another fraction, and we know that when you divide by a fraction, it's the same thing as multiplying by the reciprocal. So I'm going to rewrite 1 over cosine squared theta. I'm going to put a multiplication symbol. Instead of sine squared over cosine squared, what we're going to write is cosine squared theta over sine squared theta. And notice we have a cosine squared in the numerator and a cosine squared in the denominator, so those will divide out and become 1. What we are left with is 1 over sine squared theta. And we know that we cannot leave this as a reciprocal, so we're going to simplify. We know that the reciprocal of sine is cosecant, so our final answer becomes cosecant squared theta. All right, next up, we are actually going to do the same problem again, and we're going to do it in a different way. So once again, we have simplified tangent squared theta plus 1 over tangent squared theta. And all we're going to make use of this time is our Pythagorean identity that states that 1 plus cotangent squared theta equals cosecant squared theta. And we should get the same answer that we got when we did it the other way. What we're going to do is actually split this up into 2 terms. We have 2 terms in the numerator and 1 term in the denominator. The term in the denominator divides both the tangent squared theta and the 1. So we're going to rewrite this problem as tangent squared theta divided by tangent squared theta plus 1 over tangent squared theta. Now, if you notice, we have the same factor on top, the same term on top as we have on the bottom. A lot of people like to say canceling out. It's a scary term because people will just take it away. People will take both of these away and leave it as a 0. However, we know that anything divided by itself is actually a 1. Plus, now this states the reciprocal of tangent squared. The reciprocal of tangent squared is cotangent. So we will change this into cotangent of theta squared. And we know from here, our identity states 1 plus cotangent squared equals cosecant squared. Therefore, we're going to replace 1 plus cotangent squared with cosecant squared theta, and that will be our final answer.